In this video, we will talk about the stable and unstable computations, and we will introduce the so-called condition number. Basically, a numerical process is unstable if small errors you made at some stage of the process are magnified at the subsequent stages and seriously degrade the accuracy of the overall calculation. So we call the problem is ill-conditioned if small changes in the data can produce large changes in the output. So we will introduce a simple definition to capture any potential ill-conditioned problems. And you can suppose that we are trying to estimate a function f of x at a point x. And the question is, if x is perturbed slightly, what's the effect on f of x? And we will call this ratio x times f prime, which is the derivative with respect to x, divided by f of x. So this ratio will serve as the so-called condition number. So let's give a simple example. Suppose that you have the sine inverse x, and you want to calculate what's the condition number for this calculation of f of x. And you simply can differentiate this inverse of sine function, and that's given by this 1 over square root 1 minus x squared. And if you calculate this ratio, it turns out to be equal to this value here. So you can think about at what values of x this condition number blows up or goes to infinity. And basically, if x is very close to 1, then you can see that sine inverse of x is approximately getting close to pi over 2. And the denominator basically approaches to 0, and the condition number becomes to infinity. So in other words, if there is a slight error in your x, which is for values of x near 1, then the error will be magnified and your calculation will blow up. So this is what we mean by the ill conditions for this particular x value.